Okay, hello everyone. How are you? I hope you all are doing well and you're safe. So, we'll be starting in a few minutes. We'll wait for some time before more people join and then we can start our session. I hope you all are excited for the same. You can put up in the comment section. So, hi everybody. Welcome to our Techloop session on blockchain conducted by IEEE-VIT, an active student chapter inside Region 10 of IEEE International in collaboration with Dhive. So we have our honorable speaker, Mr. Satish Mohan, who is the founder and CTO of Thive, on board with us, who will be giving you an insight into blockchain and covering the technical aspects, the opportunities with respect to the same, and in-depth overview of the entire topic. Right. So let us get started with the session and a brief intro with respect to blockchain. So I hope every one of you has heard the term blockchain at least once in the past 1 or 2 years, right? Because that is the current buzzword that's trending with respect to tech. So I want you all to put up something that you have heard about blockchain. How did you come to hear about it, or any opinion, any thoughts about the same? Okay, Anshita says it's very secure. Okay, true. Hitat says cryptocurrency. Nice. Bitcoin. Okay, so we have quite a few intuitions about blockchain. So, okay, now let us dive into the topic. Now, each one of you were correct in some way or the other, but yeah, let's go into the details. So, from the definition, right? So, I'll start with the definition of blockchain. So, blockchain essentially is a decentralized, distributed, immutable ledger. So, don't worry if that sounds complex for you. If that sounds overwhelming, that's completely fine. That happens with every time a new person hears the definition of blockchain. So, I'll try to break down each and every term that I just said into separate topics so that you understand, and I'll summarize it at the end, right? So let us get started and dive into each and every word. Okay, so starting with the last word, that is ledger. So what essentially is the ledger with when it comes to blockchain? So you can think of a ledger in simple terms as a record of data. So let us consider a very simple example. Consider a grocery store, right? A grocery store owner also maintains a ledger with respect to the items that were sold, with respect to the items that were bought, the transactions that happened, and everything, right? So ledger is essentially a record of data that is maintained by any individual. So that is a very intuitive term. And in with respect to blockchain, right? So consider Bitcoin, because that is the most famous example of blockchain that I can give, that everyone might have heard of. So with respect to cryptocurrency, you can assume a ledger to be, analogous to the record of transactions. With respect to cryptocurrency, there are a lot of transactions that are going on, and ledger can be a record of the transactions in that case, right? I hope you all are clear with this term. So now let us move on to the second term, that is immutable. So what does immutable mean when it comes to blockchain? I think someone said in the comment section that it's very secure, right? Blockchain is very secure. So where does the security come from? Like, it's immutable. What does the term mean? The term means that something that cannot be changed, right? Immutable means something that cannot be changed. So any data that is there on the blockchain that cannot be changed. So I explained you what the ledger is, right? A ledger is a record of data. Now assume we have a technology where we store data and that cannot be changed, right? So how secure can be that? There cannot be any tampering of data there, right? So that is what makes it very secure and very, that is something that made blockchain one of the trending technologies right now. Now moving on to the third term, that is distributed. So now you all are clear with what an immutable ledger is, a record of data that cannot be changed, right? So now where does this distributed word come from? So now the record of data that we have, that is not present with only one single individual or any single entity, that is distributed across multiple individuals, right? So all the people who are associated with the system, everyone has a copy of the data. Consider any organization. Do you think that every individual has a copy of the data? No, right? So they have the data with them, they can do whatever they want with the data. It's not distributed. So when it comes to blockchain, the data is distributed, an immutable ledger that is distributed among a lot of individuals. Now moving on to the fourth and our last term, that is decentralized. So what does decentralized mean? I'll try to explain it to you with the help of an example. Consider any organization, consider a bank, right? So it is a central authority. So that specific entity has control of everything. Consider Twitter, right? Twitter has sole control of everything, of all the tweets that are there on the platform, everything. So whenever they want, they can change data. They can tamper with the data. They want, they can remove your tweet. They want, they can block you from Twitter. So that is that is they are the sole owner of everything. But that's not the case with blockchain. For example, with respect to Bitcoin, right? There is no sole owner. No one can just go ahead block you, prevent you from using Bitcoin. No one can just go ahead and tamper with your data. So that's all. To summarize, blockchain is again decentralized, distributed, immutable ledger. Ledger, a record of data that we store, immutable, that cannot be changed. Distributed, every single individual has a copy of this thing. And decentralized, there is no single authority that is controlling. It is the individuals who are using the system, they are the ones who are controlling everything. So that's what when it comes to blockchain. Varun says decentralized and distributed go hand in hand. Right, Varun? Distributed and decentralized go hand in hand because when the data is distributed, every single one, has a proof of the data, and there is where the decentralized thing comes from, that no single authority has control of everything. Right? So that is what blockchain is essentially. Now, if you have any doubts, you can ask in the chat, in the comment section. Shagun says decentralized is freedom. Yes, you're right. Okay, so if we do not have any doubts, let us move forward. And I think you all have the basics of blockchain. And now I would like to hand over the session to our honorable speaker, Mr. Satish Mohan, who will be giving you further insights into the topic and taking you further. Thank you.
Thank you, Harsh. That is a very nice introduction. Hope you guys can hear me
Yes,
well. All right,
yes, sir. You're on.
give me a second. Let me just share the screen. Well, I just want to start from where Harsh left because he gave a good definition of what blockchain and what blockchain is capable of. Now, it is an infrastructure piece, right? It is something that we can think very much like whenever we are building a system, we we do many choices in terms of what the system should do and what are the different tools that we use to build that system that will give the outcome that we are looking for. Now, blockchain is also a piece of technology like that, which we can use to solve some of the challenges that we face in the current architecture. And some of it, yes, Harsh did go in detail. Before I get into the slides, a quick note on the way. We, as a company, we focus on building systems using emerging standards and emerging technologies, and it has been done with the purpose of how can we actually use these technologies to reimagine the interactions that we do today, right? And these interactions could be any kind of things that we do in digital or physical life with physical assets, and our intention is to make sure that okay, everything that we build on digital that also should be seamlessly transitioned into the physical world as well, right? So what I would like to do with today's session is not focus on cryptos or not focus on any of the DeFi applications because they're all doing great, and that's one of the proven areas of where blockchain can be used. But let's kind of start focusing on what else we can do with a technology like this, because with all the things that we heard so far in terms of it is secure, it is decentralized, it is distributed, it provides all those kind of great primitives. Like, what are the things that we can solve using these technologies beyond the existing applications, right? So I'd like to spend some time going through this use case in terms of frictionless data exchange, because if you look at every system that we are building today, with blockchain or without blockchain, it essentially is a way to exchange data, right? These data are exchanged that is going to be checked for. These are claims, right? The data is against the claims, and those claims are going to be checked, and that kind of decides your eligibility to participate in certain transactions. So that's all the systems do. Like, it collects data, it uses the data to make decisions and give you access to those things. But this is the way it is happening today. I think there's a lot of possibilities that we can enhance it in a way that it can make it a lot more frictionless using all these technologies, right? And to go into that, I think let's first look at how things happen today, right? If you look at how the systems kind of exchange data between themselves, uh, and for this, I'm kind of using a context which has three actors. There's an issuer, holder, and a verifier. Think of it as like two different entities plus somebody who is holding all the data. That could be like you and me. We will be having a lot of data that talks about our accomplishment, our capabilities, our achievements, our ownership. These are all data that exist with us. And these data are always been issued by some organization that kind of assert that we are capable of this, or we have certain qualifications and things like that. And whenever we get engaged into a transaction, which could be opening a bank account or applying for a new position or things like that, we exchange this data with that organization, and that organization need to make sure that they're looking at the data that is authentic and they can actually verify those things. And today, one of the ways it happens is, yes, there could be a handshake between the issuer and the verifier, and the information might get verified. Now, the challenge here is like the issuer and verifier need to make sure that they have this handshake agreement done ahead of time to make sure that this verification can go through. Or the verifier might be knowing that they can actually go to a particular URL and get things verified. Uh, this kind of scenario really works when you have those kind of agreements done ahead of time, or you're thinking about one proof getting verified at a point of time, right? But when you think of how you apply for a job or how you apply to open a bank account, you're not giving one proof. You might be submitting more than one proof, and each of those proof or data is coming from multiple endpoints. So it becomes very, very challenging for the verifier to make sure that they can actually go and verify everything. And the way people do today is like the other model that exists today is like, okay, the verifier collects the data as part of a transaction, and then they take in help of an agency uh, who will take care of this verification. They go to all the endpoints, so they have mechanisms by which they can go to different endpoints and get the data verified and give the result back to the verifier. Now, this is an inefficient model, both in terms of time and money, because by the time the verification has been complete, the result could have been different. And it also adds a lot of friction to every transaction. And with the kind of progression we see on digital methods, these kind of frictions need to be eliminated, and we do have technologies that allow us to do these things today. We'll get to that in a minute. Now, one of the biggest threat, I think this is more linking to the decentralization or the distributed aspect of things. Think of the scenario by which you have data that you hold, and that data is asserting certain capabilities of ownership with you, but the organization that issued those certificates does not exist anymore, or their endpoints does not exist anymore, right? And that puts it in a very, very difficult situations by which, okay, you're sharing the information, but the verifier had no way to get those things verified because the system does not exist or the org does not exist. So these are some of the challenges that we see day in, day out when we deal with data, and especially when we deal with data in a way to engage in certain transactions, right? So the way we kind of look at this thing, I think the definitions or how we can actually use all these emerging technologies to build something that we call a trust framework. This is a trust framework that will actually connect the issuer, holder, and verifier in a decentralized way. When I say a decentralized way, is like each of this data, as it has been created, and before it's been shared to the holder, it also make use of blockchain to make sure that it is being anchored onto the chain, right? So that the proof of the data exists in a chain. Now, it is again depending on the use cases in terms of like what should go on the chain. So the model that we follow in this trust network is like we don't put the data on the chain. There is a method by which you can actually take the data, tokenize the data, and then add the token to the chain, so that when the verifier get the data, he can also create the same token. If the data is not been tampered, they can also calculate the same token and then check the token against a network and see what's the state of this data. So this kind of brings a model by which any piece of data that has been exchanged, the receiving party can quickly verify and see who is the issuer of this record that I'm seeing, or the data that I'm seeing right now, and to whom this has been issued. That is the holder that is actually presenting the data. The integrity of the data, whether anything has been changed or anything has been modified after it's been issued. And the most important thing, especially when it's been linked with a blockchain kind of infrastructure, is getting to know about the state of this data, because there are many times things have been issued, and after the issuance, okay, things might go through an updation or things might get revoked, so it becomes like invalid from that context. So how do we actually make the verifier know that, okay, yes, this used to be a valid certificate, but it is not valid anymore, right? So those are the things that comes with the fourth element in terms of checking the validity or checking the state of the data. And all of this thing in terms of the verification can happen in a few milliseconds. So this is kind of like a huge improvement, where the typical agency-led verification takes weeks to months, or even handshaking ones which needs the handshakes to be done much ahead of time. So all those things can be eliminated, and we can have a much more efficient way to get the data moving between the system. Now, to build this thing, I think we need to start visualizing what a decentralized infrastructure looks like, because it is not just a blockchain which is doing all the magic. Blockchain is a central piece to the architecture, which actually hosts the token. It actually has some of the state related to the token, and that state can be updated by the participants depending on their authority on that particular token, right? And this is an infrastructure then that can connect to various ecosystems and various services, because there could be many applications that can leverage this infrastructure and give different capabilities to different ecosystems. So we need to start think of it like, okay, this is an infrastructure that can be used to build applications or build new models in terms of how the data is being exchanged between these ecosystems. So the exchange could be like a many to one or one to many, or different kind of scenarios exist with different kind of use cases. So one of the things I really want to point out here is, along with the blockchain, when we talk about data exchange, we also need to think about the formats in which the data gets exchanged, right? How does the packet really moves, and how do we give the capability to those packet that it can be verified? It can be verified in terms of content integrity, or how do we create such envelope that can actually host any kind of data and kind of send it across a different kind of system. So there is a standard, there's a W3C recommendation on this that is called verifiable credentials. So verifiable credential is, you can think of it as an envelope with certain cryptographic superpowers, which allow you to put in any kind of data that you want to kind of send it across to different endpoints. And anybody who receives it can quickly verify those things. And when those kind of standards get integrated with a blockchain infrastructure, it gives more superpowers, right? It makes the entire exchange really frictionless. And so that's how we need to, the way we should look at the blockchain or the technologies, because blockchain as a single tool can kind of think that, okay, yeah, it could be, say, database plus. But only database is not going to help you build a system, right? You need many other elements to come in to make sure that, okay, there is a usable system that is solving something that is available out there. So the way we are building, this is more specific to the way we are building a core network, which is a decentralized infrastructure. The goal of this infrastructure is to make sure that, okay, it is a collaboratory and participatory infrastructure, which allows many ecosystems to start building their applications on it. And when they start building their applications, they have a lot of choices in front of them, because it is not a very opinionated thing in terms of like, oh, you need to make your application only using this language, or you need to kind of make use of everything that DWay makes in terms of SDKs or toolkits and all those things. No, the infrastructure is built in a way that, yes, the ledger or the blockchain infrastructure has certain capabilities, and that capabilities can be leveraged by using the platforms or applications of your choice, right? As long as it is integrated, it knows how to talk to the core infrastructure. It can allow you to build different kind of systems, and we see that there are different kind of systems that come into picture to help people to build applications in a way that, okay, how do you actually take the data and transform the data into a cryptographically verifiable data set, right? How do we manage those data transformation? I think that is what we have the SDK for, and that is one of the implementation, but there could be many, right? Okay, there could be many different ways people might think of those transformations, and we at the community side, we really focus on making sure that, okay, all those things can work with code as a blockchain framework, right? And this kind of allows people to have their choice and really unbundle the products and services in a way that it is a trust mechanism, and the trust mechanism is not limited to only doing data exchange, but there could be other services that also plug into the data exchange model or this infrastructure that can be made use of, right, by other applications, because they can all trust in a way that what the system is going to do, and they can trust the systems to say that, okay, they're dealing with things that will not cause any issues on your applications or your for your customers. So because you're doing it in a very, very privacy friendly way, right? So, and along with all these things, I think one of the things when we build collaborative and participatory infrastructures like this, key to success of this kind of infrastructures is how do we manage governance, right? How do we manage governance in a way that, how do we make sure that, okay, there are structures that allow people to put in certain kind of rules in terms of, okay, who can issue what and what kind of data is valid, and these are governance frameworks that can be implemented at each ecosystem level, because every ecosystem could be different and every way they kind of collect, share data could be completely different, right? So I'll definitely give you the links in a way that how you guys can actually take a look at these things and start visualizing applications on top of it, or use cases on top of it. Right? So one of the things I keep on talking about is tokenization, or this is a different. This is not the crypto tokens. This is as currencies. This is the data tokens that we're talking about. So if you really look at the blockchain infrastructures, I think the way it has been programmed today, I think most of the system that is available there, it uses the hash of the document, or the cryptographic hash of the document, as the unique identifier for a particular transaction. Now, it works beautifully in many use cases, but the moment we start attaching it to the real world use cases where the documents as its own life cycle, right? It goes through updates, or it goes through various kind of things, and this can happen at various point of time. And every time the transaction happened with some changes, it always produce a new hash, which makes it like, okay, if you really need to kind of manage a life cycle of a document, you need to have another layer of system that is coming on top of it, which actually aggregates this and kind of say, okay, this is a document, and all these transactions that happen at various point of time in a blockchain are all belonging to this. Now, we thought of taking a different approach in a way that we can create, when the first time the document is being added to the blockchain, or the token has been added, we kind of create a token, and that token becomes persistent, and that token has a capability to attach all the revisions that is associated with the document. And along with that, it also exposes a set of interfaces that allows somebody to query the identifier of that document and say, what are the identities attached to it, and what's the history of this document, and what's the current state of this document. And it is really, really extensible in a way that, depending on the use cases, what more things you need to kind of attach to that identifier, you can start building more and more things on top of the identifier, because it is something that stays with the document as long as it remains in the system, so it doesn't change at all. So imagine it's very similar to, say, a credit card number or a UPI identity that we have, UPI ID that we have. So it remained the same throughout the time. And this also gives us one more important primitive in a way, that this identifier that we can use to support various kind of interaction models, right? This identifier can be attached to a QR code, and then it becomes like easy to have this connect between the digital world and the physical world, right? So, or it can have this identifier carried in a RFID chips, or it can be inserted into the NFC chip. So there are various kind of interaction models that can be built to make sure that, okay, how quickly you can look at the identifier, scan it, or exchange it between systems and get to know what is behind it, right? So some of these things, okay, these things are all been taken care of within the SDK, but people who are interested in kind of playing with SDKs or playing with the blockchain code base, I think this is something that you can look into the code and suggest improvements, or there are ways if this can be made differently. Yes, we are all open to feedback. So when you deal with the typical flow, this is a very, very high level flow. When from an issuer's point of view or the ecosystem point of view, is like, these are all part of the infrastructure. All these capabilities that I'm talking is part of the infrastructure that has been exposed from the chain, from the through the SDKs. And these kind of things like the SDKs can become part of different applications or different or a blockchain node. and it allows organization to start issuing credentials, which is verifiable in nature, right? And when you do those kind of when you create and share those kind of credentials, it becomes easy for a verifier to kind of getting a copy of a credential, and this verification can happen instantly, right? It really take a few milliseconds to actually do it, and we do all these things if you look into the chain in a way that there's no personal data that gets onto the chain, right? So somebody who, because the blockchain infrastructure is a public network, and anybody can go and view through the transaction logs or the transaction history and kind of say that, like, oh, these are the kind of transaction happening, and we need to be very sure that, like, uh, we make it less correlatable, saying that, like, it's not saying that, like, oh, somebody looking into the blockchain and saying that, like, oh, they can figure out all my details in terms of who I'm dealing with and what are the certificates I hold and what are the capabilities I have. Yes, I should be able to share it, but it should not be something that is available as a public data, because one of the design pattern that you need to keep in mind while designing blockchain applications or blockchain itself is we should store less data, because the data that is put on the chain, it is difficult to erase, or it is in some cases it is impossible to take out those data if somebody don't want the data to be there. So it's an immutable infrastructure, as Harsh pointed out. So we need to be very careful when we design the system, saying that what should stay at what point. And with the model that we are creating, we are kind of showcasing the method that yes, we can achieve a frictionless data exchange without storing data on the blockchain. So it's a concept we can think of like the data remain mutable all the time, but the state remain immutable, right? The state is what the blockchain will keep track of. The state remains like, okay, is this the latest version of the document I'm looking at? Is this document currently active, or has it been expired, or has it been revoked, or anything? Any of the state changes that happen to the document, that those are things that get stored on blockchain, and that remains immutable, right? So that is how the system has been designed. So let me take a pause here, and if there are questions, I'd like to answer the question here, or I'll take you guys through some of the demos, and which will help you guys kind of understand all these things. Okay, let me go into the demos, and I'll switch the screens a couple of times, so bear with me for that. Okay, so this is one of the public repos that you can try to get an idea in terms of how all these things work together, how the chain works, and feel free to fork it and play with it, and because this allows you to kind of pull up a Docker container and host it within your system, and it does not take much of a resource. So if your laptop has more than 2 weeks of memory and has a few disk space, and maybe at least you can spare one vCPU, I think that's good to get started. So once you have this running, the Docker running, you can then run any of the scripts, right, which is out here, and I'll run one of the scripts and kind of give an idea of like what it actually does. Um, so let me, and if you guys are doing it, yeah, you can follow my demo on your machine here. All right. Is the terminal font visible? Or do I need to increase? All right. So for starting the demo, I do have a node running on my machine, which is so when you start the node as described in the code demo scripts, you are running a completely you're simulating a complete blockchain environment within a single node, right? And so this is good for you to start developing applications and kind of testing things up. And I have already clone the repo. And once you have cloned the repo and typical setups like just kind of hitting the yarn, and then there are a few things that we have on which is already populated. So some of this demos, okay, you can kind of do the yarn demo, yarn VC, or yarn demo messaging that will help you get started. Yeah, so let's do the yarn demo. Right? So let the script runs. I'll definitely help you explain what it is doing. So in an essence, what it is trying to do is I have a schema defined, which is my data model or a data structure. Think of it as like a schema that will issue you a certificate, right? Or issue an identity document, things like that. So schema is the one that gives some structure to the content. So one of the things that we do is, okay, take the schema, and the schema get registered onto the chain. So a typical schema, when it get transformed into a cryptographically verifiable format, it is at that time it actually adds something like an identifier that I talked about. This kind of identifier represents the schema, and this will not change even if the schema go through revisions, right? But what keeps on changing could be the schema hash, right? Every time there is an update or there's a change to the schema, it definitely changed this thing, but it always get attached to the same identifier, and it then has some of the aspect which attach it to some kind of a folder structure to say that, okay, all this belongs to one organization or a one folder or one event kind of stuff, and then it goes through creating the controller is the one who is actually the owner of the schema, and for the blockchain to manage some of the consensus to say that, okay, it is this identity that is actually sending this transaction. It kind of makes sure that there is a valid signature that is attached to the schema, and it sends it to the blockchain. So once we have the schema up and running, now it is the time to kind of add, say, some data to the schema, or create a certificate that is based on that schema. So when you create those kind of structures, we say, okay, I'm going to issue this, I'm going to issue it to a different identity. So these are cryptographically verifiable identities that exist on the infrastructure. Now, it does not need to be having an on-chain identity to validate these identities. Typically, the issuer will have an on-chain identity so that it can provide more details about the issuers and all. But on the holder side, this can be completely off-chain as well. It has the ability to get the off-chain identities verified as well. So once I pass a content to this infrastructure and say that, okay, this is the certificate I need to issue, it takes it, the SDK takes it, and it starts to transform the content. The transformation starts from here. It starts to transform the content, and it takes the content. It starts hashing the content in a way that it allows you to send this certificate as a whole, or you can kind of say that, okay, I want to only share my name and age, right? And that also should pass the verification, even though you have been issued a certificate with, say, 10 fields or 10 attributes. But for a given context, you only want to share two of the attributes with the verifier, and the verifier is happy with only getting those two. You can create those kind of selective disclosure from this document. We'll see that in a minute, and it can get verified, and then it kind of goes through attaching it to attaching different attributes, that is again helping in the verification stage, and again goes through the same signature verification process, and after. So this is the document that we talk about here in terms of the transformation that happens. This data stays with the application that you're building, right? It does not need to be sent to the blockchain, right? This data will either stay with the application that is issuing the certificate, or it goes to the application that is storing the certificate, like a wallet, or there is anything that is the holder is having to keep this certificate. So this is an off-chain data that happens there. And what goes into the chain as a transaction that gets submitted are these parameters. It only takes the cryptographic parameters, and we make sure that I can look, given this identifier, nobody knows, but just looking at the chain, nobody knows what does this identifier really represent, right? This has only been known to the people when you share the data with the verifier, and the verifier has an ability to know that, okay, there is an identifier attached to that data, and they can actually query against the chain and say that, like, oh, the data, the identifier exists, and then it can actually go through the checks that we talked about earlier in terms of checking the issuer, checking the holder, checking the integrity of the document, and things like that. So this is one of the other things that I talked about in terms of the updation. So if you look at here, when initially created the data, we had the identifier that has been created here. This is the first time when we created the data, and it has this hash. And we also go through an update mechanism now, which say that, okay, the identifier remains the same between these two transactions. And when I do an update, because I went and changed the name to Alice Jackson, and which actually produces a different hash compared to the hash that we have here, because that represents the change in the content, and that's the same hashing algorithm that verifiers will also do it at their end to say the content is valid or not. And so now the new hash is attached to the identifier, and that get posted to the blockchain. So, and if it goes through verifications, yes, it is all verified, and then we go and actually revoke the certificates, right, or the credentials. So once it has been revoked, and if the verifier go through with the credential verification, it is no longer valid. I think that is a quick way of kind of looking at what this technology is all about. So before I go, I have a quick look at one more additional demo, which gives you messaging. It goes through the same models. Okay, so one of the things that happened here is like the thing that I talked about. I have a credential which has all this particular field. Now, when a verifier is requesting data from me, they can actually kind of say that, like, look, they want a data that has been anchored against a particular schema or coming from a particular institution. And they say that, like, I only want to know these two things. I don't want the entire data that is part of the credential. Just tell me these two things. And it can be sent with a message, which also has a challenge. Now, this is an important cryptographic primitive that should keep in mind, in a way that when somebody sent a response back, if the holder is sending a message back, which actually gives all the details, and it only gives the particular data that has been requested, and it is a verifiable presentation that is going back, it can get verified at the verifier end, where you can check for the credential integrity, credential signatures, as well as the validity, which say that whether it is active or revoked, and things like that. Right? So now these things that happens, if you also look at on the chain side in terms of what happened on these things, let's go and take a look at the chain. Okay, so this is the chain interface. So even if you are running a node locally, you can go to apps.code.network and then kind of select and kind of say you're running a local node, so it actually projects whatever is happening from your local node, and you can kind of see here. So these are the different transactions that we did when we ran the scripts. And if you really look at this, there is a transaction which is anchoring a particular credential, and it actually got some of these details from it, and it created a particular identifier for the chain. So we don't keep any of the personally identifiable data, and things can get verified. Now, the reason I went through this deep is to get your imagination flowing in a way that, like, you can now start thinking of, like, how can we actually build systems leveraging these kind of capabilities in a way that, yeah, even if the system does not like the issuing system does not exist tomorrow, the proofs that get exchanged can always get verified, and it can always get to know the latest state of it, and the data remains valid as long as it stays in the ecosystem, right? So it can, and then there are many other systems that we can rethink using this model to make sure that we can build completely decentralized systems. Okay, so let's get back to the presentation. Any questions before I get back to the presentations? Okay, I do see one question from Lanka Vasant, and this is the liquidity pool. I think a liquidity pool is a concept when you start building systems that is linked to cryptocurrencies, and where it's completely onto the speculative cryptocurrency ecosystems where you bring in the models of liquidity pool and things like that. It doesn't exist in a data exchange model or the infrastructure that we are talking about. Okay, so let's get back. So what does this actually provide us? So all this infrastructure that we are building, the key element or the basic construct around the system is how do we actually make the providers and seekers to exchange information, and how do we help them to discover each other, or how do we make sure that, like, they can be trusted, or the interactions has that trust attached to it, so that they don't need to kind of use a third party, or they don't need to have a time consuming process that is required to kind of establish those trust. And once we kind of make those trust access and transactions seamless, it actually helps people to spend even less in terms of making these things happen. So which basically means there are more and more workflows and processes that can come into into the digitalized world, so that more and more processes become frictionless. And so think of it in a way that, yes, there is this infrastructure, and this infrastructure is just getting started. We can keep on enhancing it in terms of its capability as we start building systems. And the best way to enhance the platform capability is to make sure that what are the different use cases we try, and what are the new things that we need. And there could be new usage patterns that can emerge once we start all using these things. And the beauty of this infrastructure, or this blockchain infrastructure, is like it is not really focused on new applications that you're building, or it can also work with the existing application that is doing the job today, right? Maybe there could be applications that is doing credentialing of various types. They're producing various kind of documents. I think those all infrastructure that's been built, irrespective of whether they use Web 2, Web 3, or Web 5, whichever stack they're using, they can all get integrated into the platform we have, right? So I know that there could be this. These are a lot of things in one go, and I definitely kept it at a very high level. So each of this topic demands its own slot to go through the details and get this understanding. But I just want to kind of say that, look, if you are looking at what are the opportunities that exist, or how do we start participating um, on this infrastructure building, or building applications around it. So there are various streams that you can really look at, because if I'm talking this purely from a core network point of view, but this typical model is pretty much applicable to every blockchain ecosystem that you see, right? So that we can broadly classify it into two sides, right? One is people who are interested in building the core network. I think these are the people who are interested in building, say, the core chain parameters, or in terms like really focusing on saying that how can we improve storage, how can we scale things out, or how can we reduce latency, or how can we have better messaging models that will help us to scale from a 100 node network to a 1,000 node network. So those are all things that can be done at the core chain level. And so Core has a concept called pallet. Pallets are basically modules that can be integrated to the chains, and these modules can do can capture business logic and can be attached to the chain. So the palette is like if you want to build new functionalities that need to be integrated to the chain, the palettes are again one of the ways to start developing for code. And then the last is okay from the access point of view, saying that okay, the SDK developers and they can really focus on building things on top of the libraries that exist, or start building new libraries so that there could be different ways to consume the infrastructure. So the code is written in the Rust language, and the SDKs and most of the applications are using TypeScript. So anybody who is interested in getting onto the chain or the pallet side or the SDK side, feel free to ping us, and we'll definitely help you get started. And on the other side is about building applications, because the infrastructure is only usable or useful if you have applications that has been built on it that is actually solving some of the real world use cases. So there are different kind of applications that we can think through. There are applications that could be both web or mobile that can help organization to say issue certificates or issue documents, or do other things like maybe have linked documents in a way how the credit card works, because you think of like credit card is a one credential that have a unique identifier, but it also has a verifiable history with it, so that the merchant can quickly verify whether you are eligible to enter into a transaction based on your eligibility as well as your spending pattern, right? So those kind of infrastructures can be built using linked documents, and those kind of applications can definitely come up. There are things like off-chain attributes here. This is like, okay, your applications or your data remain completely off-chain, and you can kind of have more structures built off-chain and kind of tokenize those information into the chain. So off-chain developers development is another area, and these off-chain workers, or we call it the agents of the off-chain workers, they can actually stay in a cloud, or they can be integrated into a mobile applications or things like that. And then there are people who are interested in the infra side of things, which is about how do we build extensions, be it in terms of other wallet apps, or apps that allow better visualization of the blockchain data, or transferring blockchain data so that it can be consumed by other applications. So various kind of explorers, indexes, or archival nodes, and various kind of things that we think as are extensions to the blockchain infrastructure. So there are a lot of opportunities that exist in this infrastructure space, and it is just emerging. And when I talk about infrastructure, it is not blockchain as a project alone. It brings in a lot more elements around it to make sure that it provide usable primitives, right? And so here is one way to get started. Like all the projects that I referred here or mentioned here, these are all open source projects. So feel free to fork, play with it, and if you are getting an idea or if you're developing something, feel free to send us a pull request. So we'll be happy to review it and get it in. If that is adding something new to the infrastructure, and also kind of join our server, join our Discord server, so that we can help you get started, and maybe kind of help you with the steps to, depending on your interest, whether you want to be contributing to code, or whether you want to contribute to the SDKs, or you want to build applications that leverage these things. We'll be happy to guide wherever you want to get started, right? I think with that, I think that's the last slide I have. I'll be happy to stop here and maybe spend some time taking questions if there are any. Thank you.
Thank you so much, sir. That was a really wonderful session. I think that was really informative, and our viewers must have liked it. I think they gained a lot of information from the session. Just
Okay.
before moving on with the session, I think yeah, we can take a break now and take up any doubts. Sir, you can take notes if there are any in the comment section.
Yeah, I do see some questions around decentralized, distributed consensus and all those things. So so consensus, I think that's an important topic. I think so. Every blockchain have some consensus mechanism, and we do see different kind of consensus mechanism when we look at blockchains. And there are things like proof of work, proof of stake, proof of authority. There are different consensus model that exist in different networks, and these are protocols that are used to validate an incoming transaction, which says, okay, whether it is a valid transaction and it is doing the right state change and things like that. And those validations are done by a specific number of nodes that are called validators within the blockchain infrastructure, right? So these validators are like in some networks these are all pre-assigned, saying that okay, there are validated nodes come in, and in some networks, okay, these are typically implemented as validator pools. Like in our network, these are validator pools, which makes it like uh, the validators are selected randomly for a particular session, so nobody knows, okay, who is going to, or which validator is going to, or validators are going to validate a particular transaction. So it becomes so random, so that okay, it adds more trust to how a consensus is arrived. And when we really look into the consensus, it really validate against the rules that is set as the chain protocol, saying that okay, whether it matches all those things. It is an important construct within the blockchain world, and this is a place where we have a lot of discussions around saving energies or making it green, because proof of work is it consumes a lot of energy, and but the proof of stake and proof of authority implementations are like less, it consumes way less resources. So there is more, that's a place where most of the community is moving to across all the chains.
Yes, so I think that was the really great explanation on decentralized. I think people are clear. I think Shagun, you understood, right? Oh, if there are no doubts, I think we can move further with this session. So thank you so much again for coming on board with us and taking such a nice session. It was a really pleasurable experience for us, for IEEE, to conduct a session with Dive and you as the speaker. Yes.
Yes,
It,
yeah, thank you.
thank you so much, sir. And I think Shagun put up something uh,
Yeah, I
to
think, yeah, that's an interesting point. The ETH2, yes, ETH2 is moving to a proof of stake implementation. Yes, that will definitely have solved the energy problem. Now, uh, I think this is more from the context of like what we're building. So yes, when we talk about participatory and collaborative infrastructures like blockchain, uh, how do we use it and who uses it? It has some more attributes that is attached to that decision in a way that so one of the things, when if you really want to build it at scale, at a population scale where the real world systems are starting to leverage it, we need to have abilities where, say, there is a predictable pricing, or there is an ability where the regulators or the enterprises can start participating in the network. Because today, most of them are keeping an arm's length because of all the crypto regulations, or the need to kind of have crypto tokens to be part of this kind of infrastructure. So we need to start moving step by step, depending on what the ecosystem really demands and what makes it makes the larger ecosystem to start participating in it. And once the model start maturing, I think some of these objections that we see today will go away. But yes, energy problem definitely proof of stake will eliminate it. But we still have a challenge in terms of how do we bring in services that can actually give predictable pricing.
yes, sir. So
All right.
thank you so much, sir. I think
Thank
we'll
you.
move further with the session with that. And I'd like to hand over this session to Divina and Srishan, who will be taking this further and going ahead with other aspects of blockchain.
All right. I was about to
Yes,
leave, and I saw the one more question from
yeah,
Sagar.
one more question is there.
POS will lead to centralization. Yes and no. It is entirely dependent on the implementation, because if your validated pool has been selected in a centralized way, so that uh, like your participation is decided by a set of people in a way, this is the only way you can enter into a validator pool, yes, then it is more or less centralized. But if your entry into the validation pool is based on your reputations or your token holdings or any other mechanisms every chain comes in, that means, okay, anybody who fits into that eligibility criteria can be part of the validator pool. In that case, yes, it is truly decentralized. But I do believe that we'll get to see all kind of model before this become really matured in terms of like how we build networks which is completely decentralized. All right, then I'll take a leave now. So feel free to join the Discord, and we can definitely continue the discussion there. And looking forward to see you guys either at GitHub or on Discord. So thank you.
Yes, sir. Yep. So let and I hope Devina and Zishan would be there to take the session further. Hi Devina, hi Zishan.
Hello.
Hello, everybody.
That was quite an informative session by Satish sir.
Yes, it's been an interesting session. So it has covered a lot of aspects of blockchain.
Yes, with that, so I'll also take a leave, and I think you both can continue the session. Thank you.
Okay. So till now, we've seen about different aspects of blockchain. We've seen how it's used practically in the real world applications. But we're going to take a step back now and look at the basics. How exactly a blockchain is developed? So first, we're going to be looking at the most fundamental and basic concept that is used in building a blockchain. That is hash. So what is hash? Hash is nothing but a mathematical function. So it takes input in the form of data. Now this data can be a string, it could be a video file, an audio file, and this data is taken into the function, and we get a, a series of bytes as the output. Now, the series of bytes, which has a fixed value, the size, storage size, is called a hash. So, and the name of the function is called SHA-256, which we are using right now. So, let's say we enter some data. This data can be any data. It could be data related to any financial transaction. It could be data, medical records. It could be election votes. It could be any form of data. So, as of now, I'm just going to just input very basic transaction data. Suppose A pays B, let's say 100 rupees. So if you noticed, when I was entering this data, the hash kept on changing. So even if so as you can see, A pays B 100 rupees. For this data, we have a hash value FD67 and so on. Suppose I change just one character. If I make this 100 200, you can see that the entire hash is different. So even every data that you enter will have a unique hash. No two data can have the same hash unless it's exactly the same. So that is basically the concept of hash. It works as a digital signature for the data, and it is essentially a complex mathematical function which takes in data as input and returns a string of bytes as the output. So now, using this knowledge that we have of hash, let's try to understand what a block is.
All right, now we'll move on to a block. So before we understand a blockchain, we'll have to understand a block thoroughly. So a blockchain can basically be visualized as multiple blocks that are linked together using chains. So over here we have a block, and a block is pretty similar to a hash. As you can see in the hash, we had a data section. Just it is that the data section has been divided into three other sections. So the first section is block. So it contains the block number. So since there's only one block over here, This is the first block. So block 1. Nonce, this is another number. We'll come to it a little later. And third, we have the data section where we can enter all kinds of data we want. And finally, we also have something called as the hash. So what is hash? So hash, every block has its own unique digital signature. It is known as hash. It is basically a string of random characters. And hash represents information that is present in the blockchain. So suppose we enter some data in the data section. As you can see, as soon as we enter some data in the data section, the hash value changes. Because what is hash? As I have said previously, hash represents, it is the representation of information that is present in a block. So it does not matter what you change. Even if you change nonce, the hash value will change. Now, now suppose there's no data in this block. As we can see previously in the previous case, when there was no data in this block and there were no changes made to this block, the hash started with 4 zeros. Now it is quite unique for a block to have such a hash value, since many blocks do not have this value. This is quite unique and quite unusual in this case. Since the hash value started with 4 zeros, now that has become its case for becoming valid or signed. So as you can see, as we have changed data, the hash value no longer starts with 4 zeros. Hence, the block is no longer valid or signed, and therefore the block has turned red in color. Now, suppose we enter some data A. We want to store some data in this block. So we enter some data A or B or whatever the data might be. So after we enter data, the hash value has changed again. So how do we make this block valid again? As I said previously, hash represents information contained in a block. So one way that we can make this block valid again is by changing the nonce value to find such a value that the hash starts with 4 zeros again. We can do this manually. We can enter numbers from 1 up till we find such a number which fits our case. But this is a quite slow process. So what we can do is we can click on the mine button that is present below. So once we click on this button, we use our computer's processing power to run all the possible cases from 1 up till we find a number where the block becomes valid again, our hash starts with 4 zeros again, and our block has become valid again. So this process that we just saw right now is called mining. With this, now we have completed our concept of a block. We'll be moving on to a blockchain.
A blockchain is essentially a series of blocks which are connected in an orderly fashion. Now, you can see that in this particular blockchain, we have 5 blocks, and these are all connected. In how you might ask, how are the blocks connected to each other? So you can see that in any particular block, there is a row called as previous. And in the previous row, it has the hash value of the previous block. So let's look at block number 2. The previous row has the value 4 zeros followed by 157 and so on. What exactly is this value? This value is the hash of the previous block. If you look at block number 1 and look at its hash value, it's the same. So this manner, all the blocks of a blockchain are connected to each other, and we'll know exactly the order of the block. We'll know which block is preceding it and which comes after. Now we know how to mine and find the correct nonce value for the hash value to start with 4 zeros. Now let's say we have to make some changes, or we have to enter. Right now there is no data entered in the entire blockchain. Suppose we have to enter some data. Let's say we have to entering data essentially means making some change in the block. So let's say we have to enter some data over here. Last time we entered like transactional data, so let's enter some medical data. Suppose uh, COVID report was. So suppose this data we're entering, we can see something, we can notice something. This block, which was once green, has now turned red. That means it has turned invalid. Now, why did the block turn invalid? Because the hash value has changed, right? Earlier it was starting with 4 zeros. Now, because the data has changed, the hash value is again changed. So what do we need to do? We need to again mine and find the correct nonce value such that the hash value will start with 4 zeros, because only then will it become valid. So let's do that. Let's mine and find the correct um, hash value for this block to become valid. But one more interesting thing is you can notice that all the blocks which were in front of this, that is block number 1 and block number 2, are green. But we made the change in block number 3, and now we mined and we found the correct hash value. But suppose, and even after 3, we can see that 4 and 5 are have also turned invalid. So, suppose we make any changes, all the blocks which are preceding that block will also be changed and will also be deemed invalid, because we can see that the hash is connected using the previous rule. So then what do we have to do? We have to mine every single block so that the entire blockchain will again become valid. So we have to mine block number 4 and block number 5. Now you can see now the current hash value of block number 5, it started with 9 something, and after mining it has some other value. So once you make any change in the blockchain chain, the entire chain will be altered, and the hash value of the last block will definitely be changed. So it won't resemble the blockchain that it was previously. So there is one aspect of blockchain which we discussed earlier. Harsh had spoken about immutability. Now you can see, even though we have a very small blockchain over here, only 5 blocks, making a change creates so much havoc because it deems so many blocks invalid, and we have to again remine everything. So and imagine usually blockchains have a large number of blocks and powers of 10. So then it would definitely be impractical to make any change in a blockchain. Also, in blockchain technology, every user or every node has a copy of the blockchain. This was also discussed earlier. So if every user has a copy, then if you make a change in your copy, then you have to send the updated copy to every other user, and once they get this copy, they'll obviously know that something is different because the hash value has changed. So this way we can say that blockchain is immutable for the most case, because it is impractical to make any changes, and even if changes are made, the other users will get to know that you have tampered with the blockchain. So, okay, I think we discussed a bit too much in depth about blockchain, but I hope you understood. And now we'll be looking at distributed blockchain.
So right now we'll be looking at distributed blockchain. So we'll be seeing the demonstration. We'll understand why blockchains are immutable and why it is so difficult to change data in blockchains and why they are considered so secure. So before we do that, we'll have to understand the architecture of blockchain. So blockchain technology is based on peer-to-peer network. So what is peer-to-peer network? So peer-to-peer network is a network where all computers are considered equal and all workstations provide access to resources and data. This is a simple type of network where computers are able to communicate with each other and share what is on or attached to their computer with other users. So what this basically means is that, as Divina covered previously, is that every member of a blockchain network gets a copy of the original blockchain. So over here, as you can see, this blockchain is quite similar to the blockchain that we have seen previously. It consists of 5 blocks, right? But here you can see that there's peer A, and if you scroll down, you can see there's peer B and peer C. So for right now, for understanding the concept, we'll consider them as people. So there's person A, person B, and person C. So let's assume that all of these 3 people are members of a blockchain network, right? So as they are members of a blockchain network, they have a copy of the original blockchain. Now suppose person A wants to change some data. So person A decides, well, I'll do one thing. I'll go change data. So as you can see over here, we have a blockchain. Like the blockchain that we have seen, it only has 5 blocks, which is not the case in reality. Blockchains have hundreds, even thousands of blocks, right? So now the person A says that this blockchain only has 5 blocks, so probably I'll be able to make some change to the blockchain, and no one will be able to come to know. So this person, what he does is he goes to his copy of the blockchain and goes to the fourth block and probably enters some data over there. So as you can see, as soon as he enters some data, both block number 4 and block number 5 have become invalid because once a change is done to a particular block in a blockchain, all the preceding blocks become invalid. But since there are only 5 blocks, so he decides, well, I'll just mine them and the problem will go away. The blocks will become valid again. So he does that. And as you can see that the blocks have become valid again, right? So he has successfully made change to the blockchain and it is valid again, right? So now question you may raise a very important question is we talk about blockchain with terms like security and transparency and everything, but over here as you can see the person has made a change and his blocks are also valid. So where does security and all of it go? So as you can see, if you look carefully and look at the hash value of the last block of the blockchain of person A, just look at it carefully, right? Now we'll scroll down to person B's blockchain. Yeah, if we look at his copy, if we look at the hash value of the last block of person B's blockchain, you will see that the hash values aren't similar. Now, if you go down again to person C's copy of the blockchain to the last block, you will see that the hash value over here it is not similar to person A's hash value. In fact, it is similar to person B's hash value. So the people who have not made any changes to their blockchain, they have the similar hash, while person A who has made some change to his blockchain, the hash value of his last block is different. So this is quite a simple way to find out if change has been made in a blockchain. And since it's a network, so it's two against one, right? So one person has this copy of the blockchain, while other two people can just look at the hash value of the last block of that person's copy, and they can tell him that you have made a change to the blockchain. So this is an easy way to find out if change has been made in a blockchain. Now moving on, we will see tokens.
Okay, so till now we've just been entering random data or data in the form of string. Now tokens help us to present data in a more structured manner so that we can make sense out of it. And we don't have to be going and searching for the meaning by reading the data multiple times. So this particular tokens can have data of variety of information like your medical records, election results or votes, or financial transactions, anything. But for this example, we're taking the case of financial transactions. So between friends. So let's see, we can see over here the amount that is being given or being transacted, and the person whose account it is being taken from, and the person who it is being given to. So we can see that Darcy is giving Bingley $25, and every single block has a list of transactions, and there are multiple blocks, and this entire blockchain is defined in this manner. Now, do the principles of a regular blockchain apply when tokens are used? Of course. Jane, suppose Elizabeth is giving Jane 4.27 $4 2.27 cents. Now, Elizabeth or Jane, if they just decide they wanted more money or to give less money, they can't just make a change, because if any change is made to the data, you can see the entire blockchain is deemed invalid, and we'll have to do the mining all over again. So the principles of a basic blockchain that we've discussed till now still hold true. Whereas token is just an addition to make the data in a more presentable in a more structured manner. But there is one drawback of representing data in this manner. You know what? Because uh, the drawback is that you don't know how much a person has in their bank account. Here it's saying that Darcy is giving $25, but how do we know that Darcy has $25 in the first place to be giving it? So, without specifying how much money each person has, this entire system will not make any sense, because anyone can give any amount of money to another person, even though they don't have it. So, it's completely, then it'll be a very fraudulent system, and it won't hold true, right? So, for the purpose of making sense of the system and uh, making it in a proper manner, such that only if a person has that much money can they give others money, we have a system called as Coinbase, which we'll be looking at right now.
Great explanation, Divina. Now we'll be looking at Coinbase transactions. So, as you can see, Coinbase transactions are pretty similar to tokens, right? There's almost everything is same. So what's the basic difference? As you must have noticed that there's a new section, a new row, the Coinbase row. So what is it all about? So as you can see, we have created $100. We have created $100 of currency and we have assigned it to Anders. So we have assigned him this much money. So as you can see, if you go to the next block, you can see that Anders has made payments to his friends, right? So for example, over here you can see that Anders has paid $10 to Sophia, $25 to Lucas, $15 to Emily, and $15 to Madison. If you add all these numbers up, it is less than $100, which means that all these transactions are legit. And as we know that Anders already has $100, he can make these payments. In the case of tokens, you must have noticed that you don't know how much money a person actually has. So how do you even come to know that these transactions can happen? They are legit, right? So over here, the Coinbase transaction just solves that issue. Now over here, if you move on to the last block of this chain, if you go on to the last block, you can see that over here, Ryan is paying $6 to Carter, right? So how do we know? Because we know about Anders. We know that we assign Anders $100, but over here we can see that Ryan is paying $6 to Carter. So does Ryan even have $6 to pay to Carter? Well, the problem is quite simply solved. You just move on to the previous block, right? So over there, you can clearly see that Ryan has received $15 from Jackson in a previous transaction, which means that Ryan has the ability to pay $6 to Carter. And as you can see, this is one of the benefits in a blockchain, right? Like not only each block has its own hash value, but it also stores the hash of the previous block. So you know where you can find record of the previous transactions as well. So with this, I'm sure that you're clear with how Coinbase transactions work. And now with this, we have completed our visual demo and we have completed the basic concepts regarding blockchain. We run currencies on this technology, and I'm pretty sure you all know that they are known as cryptocurrencies. A very common example is Bitcoin. I hope you understand why blockchain is considered so revolutionary for its applications in the financial sector now. By using this technology, we ensure that not only transaction value but transaction history are never tampered with. Thus, this makes previously complicated web of transactions easier to follow and thus helps prevent fraud. I hope now you understand why blockchain is such a buzzword in these tech circles. Now, we will have a discussion on blockchain and conventional data storage solutions that are used by traditional organizations.
I think we had a very interactive visual demo, Zishan, and the way you explained financial transactions and blockchain in the end was very intriguing. So, right now, what we're going to do, obviously, now we learned a lot about blockchain, right? We learned about different aspects of it. We learned about how transactions are taking place, how data is stored, how data is sent to different nodes. So, now we're going to be looking at how blockchain technology compares to the technology which we are using in all our standard institutions, like our conventional institutions, what the form of technology we're using over there, and what and how it compares to blockchain. So, in conventional institutions, usually they're using like centralized frameworks and they're using centralized databases usually. So, yeah, now that the slide has come up, we can see more clearly. Um, so, Okay, so first let's talk about decentralization. So, one of the cornerstones upon which blockchain is developed is its decentralization. That is, every member who is a part of the network has complete access and permission to view the data firstly, and they can also make changes to the data. That is, they can make transactions, they can add data. So this makes blockchain a very transparent network, and it is a peer-based network because there is no single person who has control over the network, like an administrator as such. And that is the case of centralized databases. But since blockchain is a decentralized database, it has much more transparency. And since it is peer-based, there is no single point of failure. So, Zishan, can you tell me about how it works in conventional institutions, how centralized databases work?
Yeah, sure, sure. Why not? So, in conventional institutions, let's say banks, hospitals, and other government institutions, as you mentioned previously, a centralized database system is used for both storage of data as well as transactions. There is an administrator having full control of the entire database. The administrator is the person at the top. Administrator can add, modify, delete records on the database. The clients and other users have limited access. Moving on,
Okay, now I'm going to be talking about how a transaction takes place in blockchain. So let's look at the steps one by one. Suppose you want to pay your friend, like say 10 rupees. So first you need to request this transaction to be made on the blockchain network, and then it has to get authenticated. So how does the authentication process take place? So there's something called as a private key. A private key is like a password. It's something that only you, the user, knows, and no one else on the database knows. So it's unique for every user. So when you are making a transaction and you want it to be authenticated, there are a combination of elements that are required. So one of the things is a private key, and then is a public key. A public key is more like a username. Everyone in the database, everyone in the network can see your public key. It's not like private to you. So there's a public key, there's a private key, and there's the message. So even if, as we saw in even the basics in hash, if you change the message even slightly, the hash value gets changed. So a combination of the message, public key, and private key will give you a unique transaction ID, and this will make your transaction the as it will make your transaction very unique, and it'll so what will happen is this transaction will then be put in a block. So no two transactions will be same, and no one else can make the transaction for you. So now that this transaction has been gone to a block can have multiple transactions. We saw in the case of tokens and Coinbase also, we saw how multiple transactions are stored in a single block. So this transaction will go to a block, and then once the block has a sufficient number of transactions in it, it will be sent to every node which is participating in the network. So every person who is a part of the blockchain is considered a node because they have individual servers. So each server is considered a node. So this block will be sent to each node. And suppose you're on the receiver's end and you're just getting a block, you won't just add it to your blockchain just like that, because we don't know if this block is valid, if the transactions in the block are valid. What if someone else is posing as another person and trying to do some fraudulent practices? So even at the receiver's end, a validation takes place, and something called proof of work is also comes into play at this stage of the blockchain transaction. So the nodes receive a reward for the proof of work in cryptocurrency. So this cryptocurrency, the reward will be given in terms of cryptocurrency like blockchain and etc. But what is proof of work firstly? So proof of work is an original consensus algorithm in a blockchain network. So it's an algorithm which is used to confirm the transaction, and once the transaction is confirmed, the block is added to the chain. Suppose the original block had four blocks, blockchain had four blocks, and now the fifth block is added. So this information that the blockchain has been expanded has to be transferred to every single server in this network, right? Because blockchain is decentralized. So the updation takes place, and the information about the new blockchain is then spread throughout the network. And once each person, each node in the network has the updated blockchain, we say that the transaction is complete. So this is exactly how a transaction takes place, and we saw the demo and we saw exactly how each individual thing also works, like how a block becomes a blockchain and how we have Coinbase. So I hope now it all makes sense to you, and you can understand how you get proof of work and like reward in terms of Bitcoin, and how exactly the transaction takes place. So I think we can move forward now and discuss further.
so I've been thinking about it since in the previous slides you have spoken about decentralization and peer-to-peer network, how everyone is an equal in the blockchain network. I have a doubt. Like, wouldn't it be more convenient for any organization to have a dedicated person or like a group of people in charge of managing their entire data and database rather than everyone in the organization adding and modifying to the database. So how does blockchain offer this?
Okay, so blockchain, the chain of authority in a blockchain is very different. As I told you, it is completely decentralized and it's a peer to peer based network. So we do not have a particular administrator who's controlling the entire network. But Zishan, don't you think if there's an administrator who's controlling the entire database, it might be convenient in some aspects, but it's also a bit risky, don't you think? Because one person has so much of control, even if they make a slight mistake and suppose delete the entire database, there's nothing that can be done. There's like a single point
Right.
of failure over here. But in terms of in a blockchain, every single person has the updated copy. So there's no way that even a hack will attack every single person on the database. So I mean on the network. So I think that makes the authoritative framework in a blockchain slightly more secure. I mean, and also, but this also has a drawback because let's say in a private network, people don't want everyone to know about their transactions. They don't want their business to be shared in the general public, right? So for that also blockchain has a solution. We have something called as a hybrid or a federated blockchain. Private institutions can customize the permission requirements and implement such a blockchain, and they're not like a regular blockchain which the public can access. They are permissioned and only people who are part of the organization can access it. We'll be looking at the hybrid or federated blockchain in detail a bit later.
So let's talk about architecture, shall we? Like a database is based on client server architecture. Here, the clients act as the receivers, where servers act as centralized processing units. The communication between client and servers are maintained through a quite secure channel. It is a highly successful architecture because not only can it work for small scale organizations, but it also can be scaled for larger companies and organizations. Don't you think this makes centralized database systems a much better option due to their scalability? Like, what about blockchain's architecture?
Okay, so blockchain, on the other hand, uses a distributed ledger network architecture. It's a peer-to-peer enabled network where each peer can like connect to another using secure cryptographic protocols. So there is no centralized node, and since there is no centralized nodes can collectively take part in the consensus algorithm. So one of the most popular consensus algorithm is proof of work, which requires miners to like they solve complex mathematical equations to validate the transactions over the network. We saw this in detail when we were looking at a transaction in blockchain. So because regular databases don't require a consensus algorithm and they're completely dependent on the centralized approach, um, don't you think that puts it at a bigger risk because the administrator obviously controls every aspect? So it's more prone to hacks because the hacker has only one target, not 100 different targets. Also then yeah, so unlike even in the architecture side, when you look at hybrid blockchains, it's more like similar to a regular database, but it's not as, let's say, um, when it comes to a regular database and a public blockchain, I think a hybrid blockchain comes somewhere in between. So but generally also I think blockchain is more peer-to-peer enabled when it comes to architecture.
All right, let's. But what about the ease with which data can be stored and retrieved? Like in traditional data storage systems offer great functionality with ease of use. In traditional databases, data can be stored and retrieved much easily. To ensure proper operation of application, CRUD is utilized at the primary level. So CRUD stands for create, read, update, and delete. This also means that data can be erased and replaced with new values if needed. In case data is to be updated, it can be updated in existing records in a centralized database. While in case of a blockchain, to update or delete data, we need to add data into a new blockchain. So, can blockchain even compete with centralized database systems when it comes to handling data?
So blockchain obviously works very different when it comes to data storage. Blockchain supports immutability. which means that data once written cannot be erased or replaced. So immutability means that no data tampering can also happen in the network. So traditional databases don't exhibit immutability and hence are more prone to being manipulated by a rogue administrator or third-party hacks. But whereas in blockchain, that is not the case. And how exactly does data handling take place in blockchain? It takes place through read and write operations. So in read operations, it's used to read or retrieve data from the blockchain network, and write operation is used to add data and information to the blockchain network. So that is how data handling takes place in blockchain.
All right. Now let's take an example, shall we? If there's a company, right, and that uses blockchain for storage of all its data, including project reports as well as the financials of the company. And obviously, the company doesn't want employees to be able to see its financials. But since all the data on a blockchain can be viewed by everyone, the company is not able to achieve this. While on the other hand, databases support confidentiality. Users cannot verify information if they want to. However, it is only the administrator who can make a set of data public. But still, verification of data cannot be done on an individual level. Do you think blockchains would be able to provide the same level of confidentiality when required?
So, in terms of confidentiality, obviously blockchain is lagging behind because it is completely based on, it's completely public, available to anyone on the internet. They can just open it, access it, and become a node. So, obviously, public blockchains do not offer confidentiality as such, but don't you think this is also a plus? Because of the immutability, nobody can tamper with the blockchain. So this brings about a greater level of transparency in the system because every user gets a complete history of transactions. They don't need to depend on, like, let's say, an administrator. They don't need to go to somebody and see the transactions from their side, and that also you won't know whether to trust or not. People might manipulate and give you the data just to like please you. But when it comes to blockchain, every single person has accurate records which with themselves only. They don't need to go anywhere. So obviously this improves transparency, and it improves the trust in the system because it cannot be changed and it cannot be tampered with. So that offers greater levels of transparency, which can be a good factor, I feel.
I agree with you. But let's move on to something else, right? Let's talk about the cost to implement all of this. Centralized database systems are old technology, okay? People have had experience using them. Thus, it becomes easier to maintain and implement. It is also more economically feasible. While blockchain is relatively expensive to implement, since it requires a huge amount of computing power, servers, and electricity. Don't you think this is one space where blockchain lags behind?
Yes, blockchain, I agree. It's much more expensive. It requires more computing power. But that's because, blockchain is a relatively newer technology. And databases have been around for decades now. So there have been advances in optimization and efficiency. So blockchain, when it ages a little bit, when we are advancing and we get more familiar with blockchain, I think it'll become more cost efficient. But as of now, it is comparatively harder to implement and maintain.
Fine. There's another point I would like to discuss, and that is performance. You see, performance of data storage systems is of great importance to organization and companies. Thus, the speed of execution is also a critical aspect if we are to compare both blockchain and database. Databases are known for their fast execution time, and they can also handle millions of units of data at any given point in time. With this, databases also offer greater scalability. But do you think blockchain can offer this?
So blockchain is definitely it has additional functions. In databases, one person manages it and does and verifies and does everything. But in blockchain, we it's a more complex technology because it involves verification. It involves a consensus method to provide rewards. So it's very computationally heavy, and a lot of complex mathematical operations are taking place in blockchain. So because of that, definitely the performance time will be reduced a bit. But at what cost? we are trying to implement higher security and a better, a more efficient network, right? So I think it's worth it, if you ask me.
Yeah, I do have to agree with you on that. So, after the discussion that we have had now, like, I think I finally understood what can be the best use cases for a database. I believe that databases can be very efficient tools if they are used to run apps or systems that utilize data, that utilize the continuous flow of data to store confidential information, for processing of online transactions as they need to be fast, to run apps or systems where data verification is not needed, and to store relational data.
And I think with the discussion, we can say the best uses for blockchain are places where you need high transfer value, high storage value, in case of monetary transactions, and in places where you need trusted data verification, voting systems, and decentralized applications. Okay, finally, we come to the topic of hybrid or a federated blockchain. We've been putting this off for the end because I think now everyone is very clear with how a regular database and a public blockchain works. So now finally we can look at how a hybrid or federated blockchain works. So we'll have a look at different aspects. First, coming to the type. So database is completely permissioned. There is an administrator who controls the database, so it's permissioned. Whereas public blockchain is public and it's controlled by the peers of the network. Whereas hybrid or a federated blockchain is permissioned and only the people who belong to that organization have access to that blockchain. And let's say control. So database is centralized, public blockchain, as we all know, is decentralized, and hybrid blockchain is it has a few centralized features, but it is mainly decentralized. And when you come to architecture, databases have client server architecture, public databases have a peer to peer architecture, and hybrid or a federated blockchain has a closed peer to peer architecture. That is, it is still accessed by all the nodes of the blockchain, but the number of nodes is restricted, and the nodes are restricted to those members of the organization, as I said before. And data persistent, that is mutability. In database, the data is mutable, that is, you can make any changes, whereas in any kind of blockchain, federated or public, no changes can be made to the data, it is immutable. And let's look at chance of failure. Chance of failure is possible in a database because there is a single point of weakness, which is the administrator server, which can be prone to hacks and also negligence or any mistake by the administrator. So there is a chance of failure. And whereas in a blockchain, there is almost like no chance of failure because obviously every node has a copy of transaction. So even if someone attacks one node, the other 99 nodes who are part of the network, let's say if it has 100 nodes, still have the entire transaction history. So it's not like you can take down an entire network. And when it comes to performance, databases are obviously very fast because of their technology, and public blockchain is slow because it's computationally heavy. Whereas hybrid or federated blockchain are slow to medium. They are faster than regular blockchain because of the restricted number of nodes and the permission system that they have. So now that we have, I think now we've looked at these points at least two times, each of the points, and we had a very interesting discussion, Zishan, about different aspects of blockchain. So I hope all of you have understood um, how blockchain compares to a public database and things like that. So I now we're going to move on to something a little bit interesting. So blockchain is a buzzword that you hear everywhere, right? Blockchain, Bitcoin, cryptocurrency, and people just tend to confuse what it is. Sometimes I before understanding and before learning about blockchain, even I thought Bitcoin was blockchain and cryptocurrency and blockchain are the same thing. I didn't understand what was technology, what was the currency. So there are a lot of myths that are going around. There is a lot of false information, a lot of myths, some of them pretty interesting actually. So right now we like to take 10 unique and interesting myths and try to provide you the correct information and help enlighten all of us. So Zishan, would you like to continue and give the first myth?
All right, so let's start. So, myth number one, blockchain is Bitcoin and Bitcoin is blockchain. So, it is a common misconception that blockchain technology and the cryptocurrency Bitcoin are the same thing. So, Bitcoin was the first widely known or adopted use case of cryptocurrency that was built on the blockchain technology. So, as we have seen previously, blockchain is a database of transactions that is stored in a distributed form across a number of computers, as covered earlier, known as nodes. And each node has a copy of the database, which is basically peer to peer network, right? Which we discussed again. So when a transaction is entered, it is sent to all network nodes, which solve mathematical problems to confirm its validity. Validated transactions are clustered together into blocks, encrypted, and added onto preceding blocks, forming a chain of data that lists all the records. So we have seen this previously, right? We have seen how transactions are made on a blockchain, and I hope you have understood this. So Bitcoin, on the other hand, as all of you may know by now or may have an idea, is a decentralized digital currency. It is like an asset that can be bought, sold, and exchanged directly without the need of an intermediary, right? So transactions on the Bitcoin network are verified by nodes, right? These nodes are called miners. They race to solve mathematical problems. So miners of this Bitcoin network, they are rewarded for their efforts in new Bitcoins. Moving on to our next myth.
Myth number two, blockchain is only relevant to finance. So, cryptocurrencies can be credited for bringing blockchain into the limelight, but the two terms are not synonymous. Blockchain is only the technology which is behind the cryptocurrency, but it has multiple use cases across the industry. For example, due to its decentralization and resilience against tampering, companies have used blockchain to implement more stringent security measures on their data. Supply chain operations, online voting, digital vaccine passports, loyalty programs, source verification, repeatable business procedures, and identity theft protection, among others, are some areas where blockchain could dramatically improve the efficiency.
Moving on, myth number three, Ether and Ethereum are the same thing. Though Ether and Ethereum are often used in the same context, they are completely different. So, Ethereum is basically an open software platform that is based or built on the blockchain technology. The main advantage of Ethereum is that it helps developers build and deploy decentralized applications or dApps. So, Ethereum helps developers create operations based on their needs. And this means that developers can build thousands of various applications. So, Ethereum is not owned by anyone, right? It is a network. But the programs and services that are linked with this network, they need computing power. And this power is not free. So this is where Ether comes in. So Ether is a digital asset bearer, similar to a security or bond or a stock, and it is a solution to the issue of payment. So Ether functions like cash in the sense that it does not require a third party for approving or processing the transactions. But we have to keep in mind that Ether is not exactly a digital currency. It can be considered like a fuel for the apps on the decentralized Ethereum network. So let's understand this with an example, right? So suppose that there's an app on the Ethereum network that allows us to create, modify, and delete simple nodes. And suppose you want to maybe you have made a note on this app and then you want to maybe delete or change that note, right? So to complete any task, the app would definitely require some processing power through the network. So for covering the cost of this power, you will be required to pay a marginal fee. So how do you make the payment? You make the payment using Ether. So Ether is the token that you'll use to make this payment. So to sum up, the main difference between both Ether and Ethereum is that Ether is the fuel used to power the network, which is known as Ethereum, right? So with this, we will move on to the next myth.
That was quite an interesting myth that you busted, Zisha. Okay, so myth number four, Cryptocurrency is primarily used for illegal activities. There are concerns now among regulators and governments that blockchain technology, in particular because is applied for cryptocurrency, has potential to facilitate illicit activity. Cryptocurrency organizations and blockchain forensic companies dispute this, pointing to research such as that conducted by Chain Analysis, which found that in its second annual crypto crime report, that 0.34% of all cryptocurrency activity in 2020 was linked to illegal activity. It must be understood that such research does not necessarily include all forms of crime, and that it only accounts for crime that is understood or known about. So the real figures may be higher. Also, it's important to note that given the nascent nature of cryptocurrencies, the number of law enforcement officers and agencies specializing in this sort of crime is still quite small.
So, moving on, myth number 5, there's only one cryptocurrency. It is a common misconception among people that there's only one cryptocurrency, and it is Bitcoin. It was due to the widespread popularity of this cryptocurrency that blockchain technology even came to limelight. But since then, a number of cryptocurrencies have come into existence. As of March 2022, there are 18,000 cryptocurrencies. So, though many of these cryptocurrencies are not known about because they don't have much high trading volumes or high prices. Some of these cryptocurrencies enjoy immense popularity among dedicated community of backers and investors. In fact, after the 2017 Bitcoin crash, everyone thought that the Bitcoin bubble has finally burst. But actually, what people did not expect is that the number of cryptocurrencies increased. So there were more number of cryptocurrencies that came into existence after the crash. So it is quite interesting to see that the craze for cryptocurrencies and blockchain technology grows exponentially every day. Moving on to the next myth.
Myth number 6: blockchain is infinitely scalable. Now, one of the biggest problems with blockchain usage as a transaction platform is the time that it takes to complete blockchain transactions. So, high value cryptocurrencies are the perfect example of this shortcoming. So, Visa, for example, can process around 24,000 transactions in 1 second, whereas Ethereum and Bitcoin only manage around 30 and 7 respectively. For this reason, scaling up blockchain can present some challenges. So, the main factors which are affecting this are: the first factor is the limitations. So, increasing length of the blockchain, that means the blockchain history, could cause the blockchain to fail. There's also the issue of hardware which is required to operate the nodes. The next factor would be transaction fee. As growing blockchain requires more computing power, so they attract greater fees. And then we have the factor of block size. There's a debate that is going on like in blockchain circles right now about increasing block sizes so that more transactions can be accommodated. And a large number of projects are also being worked on. So this is bound to improve in the future. And the last factor is the response time. The more popular that a network is, the longer the validation process. Bitcoin, for example, needs around 10 minutes to build just one new block. So that is the level of high response time that is being taken in popular currencies.
Right. Moving on. Myth number 7. Everyone is anonymous on a blockchain. So, on a public blockchain, as you have known by now, that transactions are visible. But there's a twist. Identity is decoupled from these transactions. The parties in the transactions are represented by blockchain addresses, which look like a random string of characters, right? So, for transactions carried out on a blockchain systems like cryptocurrencies, it is often assumed that identities cannot be traced. So, in reality, this technology is not based on anonymity, it is based on pseudonymity, right? To take the case of Bitcoin, whenever we make a transaction, our wallet address is kept in the records and is accessible to everyone. But until no one can correlate our wallet address with our identity, real world or digital, we are pretty much anonymous. So it is only when someone can link the two is our cover blown. Till then, no one knows. Okay, right? So it is this entire system, blockchain, is a pseudo anonymous system by design, right? So moving on to our next myth.
Myth number 8: blockchain is immutable. So, blockchain works, I'll just like to revise some facts right now. So, blockchain works by combining different blocks of information, and each of those is given a digital signature in the form of a hash value based on cryptographic principles. Now, each block carries its own hash value as well as that of the previous block. This makes the system resistant to tampering because changes need to be made on each server in the system. So all the more extensive networks can enforce greater levels of security, attacks can still be orchestrated for slightly smaller and private blockchains. For example, there's this 51% attack. A type of blockchain attack can occur if a group of participating individuals they control the majority of the network's hashing power, then they threaten the immutability of the blockchain. This can also lead to a double spending attack in case of cryptocurrencies, wherein high value transactions can be reversed and amounts can be spent a second time. Moreover, the improvement in the computing powers has made it easier to carry out such attacks, especially in smaller networks.
Moving on, myth number 9, blockchain implies efficiency. So, as I've said previously, blockchain is a buzzword now, and interest of people towards blockchain grows exponentially on a daily basis. So, more and more people are interested to get into blockchain, and everyone's excited about blockchain. But with all of this buzz, we need to make sure, we need to keep in mind that it is no magic wand, right? So, it can't just make everything better. Some sectors, though, have genuinely benefited from it, and it has made the systems faster and more efficient. However, it cannot work like this for everyone. Some businesses and organizations might be better off with centralized non blockchain solutions. So, a thorough analysis is required before anything is implemented. As we have covered previously, blockchains right now are a little expensive to implement. They require servers, computing power, and lots of electricity, right? So smaller organizations and businesses may be better off not switching over to blockchains for storage of their data and transactions. So moving on to the next myth.
Myth number 10: data on blockchain is public. So, confidentiality in blockchain is never a given. It depends on whether the blockchain in question is a public blockchain, that is, it's permissionless, or a private blockchain, that means it's permissioned. In a public blockchain, anyone can join the network, view the transaction history, and become a node. However, transactions are identified using a public key, which is derived from the privately held key, rather than their information. So, transactions are pseudo anonymous by design. Whereas on a private blockchain, such as that operated by a bank, for example, users need authorization to read, access, and write information. Thus, access to private blockchain can be restricted and the information can be held or kept confidential. So, with this, we come to the end of all the myths that we have discussed till now. I hope it has been interesting for you and you learned something new. We'd like to take up some questions right now. If anyone has questions, please put it in the chat box. We'll try to address it now. Looking at the chat box, I can see that most of the questions have already been covered by Sir. If anyone still has any doubts they want to clarify or any terms they don't understand, please let us know.
Uh,
Okay, looks like we have no more doubts, right, Zisha?
Nishchay over here says Monero, my beloved. Yeah, man. Even I was a big fan of Monero coin. I used to mine it back in 18. Yeah. So yeah, we are. I'm personally hoping for a Monero comeback. Back then it was a big thing. So right, seeing no other questions, then
I
let's
think we can
conclude this
conclude.
session.
Okay, so thank you all for joining the session. We hope you learned something new. We are putting some feedback forms in the comment section. So if you have the time, please go fill that. And yeah, thank you for giving your time and listening to this entire session. We hope it's been useful, and it's definitely been enjoyable for me and Zishan to conduct the session.
All right then. Good night, people.